Hello, good morning. Today we will be solving the island problem, or that is so-called matrix problem. Sometime what we have to do is we need to find some values from the matrix, or we need to traverse a matrix, or 2D array, you might say, call it. So for that we will be using DFS, BFS, like breadth first search, depth first search, and we will solve some of the problem of them. Okay, let's start. So here we can see this is just an introduction. Like many coding interviews problem involve the traversing the 2D arrays using DFS and that's okay. Let's go to the problem once. Okay. Now, yeah, this is a problem. So number of islands we need to figure out. Okay. So given a 2D array containing only ones and zeros, count the number of islands in it. And the island is connected set of ones and the surrounded by the either an edge or zeros. Each cell is considered connected to the other cell horizontally or vertically, no diagonally. So if you see this one, for the in example 2 itself, here you can see input matrix is this, and then you can say, okay, let's choose the output of it, whatever it is. So now you can see for this one we have this example, and here I can see these are the connected ones and these are the another connected ones and this is the another one, right? So what we can do is, let me connect my system. So in this problem, what we can do is we have a matrix, something like this, and yes, and suppose here is 1, 1, 1, and here is 1, then 1, 1, 1, 1, and then 1 is here also. And now I will be making them yeah, colorful, so based on their island. So these are connected because these are connected with this horizontally, and this is connected with this with vertically, but this is not connected to this one. So what we can do, we can change the color of the pen, we can use green one. So here these are connected, and then again this is connected to itself, not to anyone. So now we have three of them. This is one, this is two, this is three. And how can we solve this? Look at the solution. What we can start doing, at least we need to traverse whole of it. Okay, because then why we can do anything. So we will going to be traverse it. So traverse whole, we will going to traverse it, that's okay. Now to track the traversal, what we need to have is a visited node. Visited, is this met is it visited or not? So we can have a visited matrix that will tell us this node is visited and this is not. And then what we can do is we can create a loop in which we will search for the connected ones only. Suppose initially we were here. If the if it is vertically connected, so there must be something, and if it is horizontally connected, then there must be something, right? So if there is nothing in vertically, then it will gives it back ki there is nothing. Stop searching it, and then it will search for horizontally again. And if it is there, then it's go deep and to deep, and until there is it finds nothing, then okay, then it come back here, and then again search for vertically, then come back and then search for vertically, and if it found again, then it will search for horizontally, and then if there is nothing, then it search for vertically, and then there is nothing. So now it will come back to again this same node. It will say okay, I'm not able to find anything, not finding anything, and done. I'm done, right? So first search is done, and we find our first island. And similarly, we search for other places also. Simple as that. Okay, let's start building the okay, let's start writing a pseudocode. Pseudocode look like this. So we will be having a visited matrix, right? It will be same n cross n, and then we will be have right like traversing it. So for columns I, then for rows j, and then if ijth cell is already visited, okay, not visited, okay, if it is not visited, okay, if ijth cell not visited, then we'll do something. अगर ये already visited है, then we don't care, right? And yeah, we don't care exactly. So one more thing, we want to have it a stack or queue, whatever we want, it's okay. Because if we are looking for a depth first solution, then we would need a stack. If we are looking for breadth first solution, then we'll need a queue. Both works. Anyone will work here. So I will taking a stack here. Okay. So if it is not visited, then what we will do, we will yeah. If it is not visited, then we'll create our while loop and start the journey. And while loop says, okay, once more, one before doing that, we will push this particular stack dot push into the, or yeah, append, you can do stack dot append. In Python append works. So I mean just push into or yeah, stack के अंदर डालना है ये बस I comma jth. So now I know कि I and jth are in the stack, and now what we'll do, we'll start our while loop that will check all the connected nodes, and then we'll say कि until stack length is there, stack is not empty. अगर ये नॉट एम्प्टी है तो विल डू समथिंग, एंड यहाँ पे हम मार्क कर देंगे ये विजिटेड हो चुका है, विजिटेड आईजेथ, राइट, क्योंकि स्टैक में गया तो दैट मीन्स इट इज विजिटेड. नाउ this is done. Now we'll start visiting all the others. So we'll say कि visit, okay, it depends on us, we want to visit horizontally first or vertically first. Okay, so let's start visiting horizontally first. So visit horizontal, and then push it. Or maybe we can write some logic here. The logic is about and one more thing, if we are starting something here, it must be like it should present a value of 1. So if not visited and I comma j has 1 value, because if it is 0, then it doesn't matter, right? Okay, if it has 1 value, in that case, then what we will do, we already visited the one. Now and now what we can do, or else maybe we will say else agar it okay, we can say else if uh, has a zero value, then we'll mark it visited, mark visited. Okay, cool. And then we were here, we're writing if stack is not empty, then we will start doing it. We will start doing visiting it while stack is not empty. We will say okay, stack dot सबसे पहले तो निकाल लेंगे स्टैक में से. So we will get the current value. Current बराबर I comma j, and then uh, push push current, push horizontal. Okay, push current vertical and push horizontal vertical. So now horizontal and current both are there, right? And or what we can say ki if value is 1, if, so there won't be the negative scenarios. If or maybe we can do that, no, not a big problem. हाँ, तो उसके लिए अपने को ये करना पड़ेगा, we have to do this. If ij equals to 1, if it has the value of as a 1, that means if it has the value of 1, then we'll push them. Then we'll say कि stack में push करो vertical and stack में push करो horizontal, and mark both of them, mark both visited, visited, right? Both visited. And then जब ये खत्म होएगा while loop, whenever it ended, then we'll increase the okay, यहाँ पे एक one more variable we will need, that will count the islands, count island, count island. तो we'll increase the count island बराबर count island plus 1, एक से increase कर देंगे. And this is the solution for this. Okay, now I'm going to implement it. So here is the solution for that. So as we discussed in the pseudocode, we have started with the total islands that will count the number of islands. Then we have m and n, the length of the matrix from the row, number of rows and number of columns. And if both number and rows and columns, any one of them is zero, that means we can return the zero itself that we have initialized it with. And then we have this visited. So we are creating a matrix which has m cross n length, exactly similar to the matrix that we call as visited, and we are initializing it with false value. Now we started with I and j, iterating it from 002 and 0102 that way. And then this, in this iteration, what we'll do is, if the matrix ij equals to 0, if the value itself is 0, that means we can just mark it visited and then continue, right? And if it not 0, that means now onwards we can start our journey. So if it is not 0, that we confirm by this line, because after anything going after beyond this particular piece of code, that means for that ij definitely be 1. And now we'll ask them ki it is not visited at least. If it is visited, then it doesn't make sense. So if shouldn't be visited, and if it is not visited, then we'll checking, we are creating a stack, because we will be using DFS, depth first search. And then stack में append कर देंगे this I and j को. Okay, that will start our journey itself. And then visit the ij equals to true, because it is appended to stack, that means it is visited, right? And then while len stack will say current I, current j barabar stack dot pop. So that will give us a current I and j will pop the stack. And then we are printing something that was for debugging, because I missed one few things actually, right? What I missed earlier is when I was talking to you the same thing. Okay, where is this? Yeah, here we are. And if I start following the design alone, then you will see. So earlier, what we I told you that, okay, this is the matrix, and I was telling you, okay, if this is an object, we need to just add the vertical ones and horizontal ones. But I forgot one thing. If you are here, okay, at this point, and then you have to add this side and this side, this side and this side, both the sides you have to push in the stack if this is a 1 right now. Okay, so that's I miss initially, but then I figure it out and then resolve it. So now you can see, so first wale mein we are adding the j plus 1 like horizontal right side, and then second one here we are doing vertical bottom one, and here we are doing as horizontal left side. Here we are adding a vertical upside. If they are present, we have to check these conditions also. Ki maybe current j plus 1 is not available in the matrix or those kind of things. And if then I run it, it is working fine. So I think we can move to the next question now. So here we are at the second question. Given a 2D array containing only ones and zeros, find the biggest island in it. Write a function to return the area of the biggest island. An island is a connected set of ones and the surrounded by either an edge or zeros. Each cell is considered connected to the other cell horizontal or vertical, not diagonally. The same problem is here, but now we have to find the biggest island. So what we can do is we can calculate the number of the nodes ones in particular island, and then we can compare as and when go right. So I'm directly writing the like implementing it instead of telling you how we'll do it, because we already do that. Okay, so we have solved the problem here. What I did is exactly the same as we did in the last problem. Now we are just what we are doing is biggest area we are trying to find, and everything is same as it is. Instead of stack, I'm using queue. That's just an experiment. It's not a big deal. Everything is same. But what I'm doing here is I'm calculating the local area of an island. So as soon as we get to find, okay, okay, now visited has the one, so we'll go to know, okay, now area, this will be the local area for that particular island. To calculate that, what we are doing is in this while loop that traverse the, one particular island, in that whenever we get the value as a 1, we are setting the area or increasing the area by 1. And after the completion of the traversal for that particular island, we are checking if the area for that particular island is greater than the biggest area, then we are setting it, else we are not. Simple as that. So we have just run it. Okay, yeah, it is passing. Let's move to the next question. Okay. So here is the problem. Any image can be represented by 2D integer array where each cell represented represents the pixel value of the image. Flood fill algorithm takes an starting cell, okay, pixel and the color, and the given color is applied to all horizontal and vertical connector cell with the same color as that of the starting cell. So recursively, the algorithm fills cell with the new color until it encounters a cell with the different color than the starting cell. Okay. And the given matrix starting cell and the color and the flood fill the matrix. These are given. So given a matrix, a starting cell and a color, and flood fill with matrix. So let's see what he is trying to say exactly. Hmm. Okay, let me follow myself again. So suppose we have the matrix, like similar kind of matrix as we can see here. And what they are trying to say is, okay, let me clean it a bit. Okay, now it is clean, we can say. Okay. So suppose there is already 2, 2, 2. We are representing the color with the numbers actually, right? And then it might be look like 2, 2, 2, right? And then here also 2. Okay, one more thing I want to check is Is it only the connected nodes we need to fill or all of them? So the given color is applied to horizontally and vertically connected cells with the same color. Okay, with the same color. Okay. So suppose there is 2 2 2, and we have for other ones we have my like 3 1 5 7 8 0 0 0 0, and suppose we also have 2 somewhere here also, right? So what the problem says, if we given you the starting point as this one, okay, this is the starting point. They are giving us a x and y. That will tell us, okay, this is the starting point, and then they will also give the color number. That might be 20. Okay. So what we need to do is we need to fill that 20 color in each of them wherever the same two is connected to the other. So initially we don't know like what value can be in there. So initially what we'll do is we will initialize it. We will say, okay, color or current color or the previous color, yeah, or the previous color is equals to 2. Now we, okay, not 2, it will be like matrix and with starting condition के साथ, तो वहां से we get the value in the previous color. Now we have the previous color, and now we can start using the DFS and BFS, and it's okay. You can use stack queue or recursion. Let's try this time recursive way of doing it, right? Okay, let's do that. So we are here, we have the previous value, and now we need to fill the next value, sorry, new value, right? New value we will be given as a color, named as color, I think. Let me confirm that. So they will be giving us a, yeah, new color ke naam se. So they will give us a new color. So what we can call it as a, we can call it a old color maybe. Yeah, old color. Now we'll start our journey. We'll write a method to DFS, DFS traversal, in which we will pass the matrix, we'll pass the starting point, we pass the old color, and we will pass the new color to fill it up, right? And also pass the visited one, visited node, because we don't need visited though, because this is one time thingy, right? So we can create visited inside it and then do it. No, we need a visited. Yeah, we need a visited. Okay, cool. So first of all, we check, is it already visited or not? Okay. One sec, one sec. Visited is this thing, that's okay. But what we need, matrix we definitely need. Yes. We need the current node. The current node will be X and Y. Definitely we need that. And then we need the color, the old color, to check the is it good or not, and then the new color to fill that value in it, and then and then visited, I guess. Yeah, these are the values that we need. And first of all we'll check x y are good or not, good enough or not. So सबसे पहले mn calculate करेंगे. That will be the matrix len, like matrix row and columns, number of row and columns. So they will become row and columns, rows, columns. So now we have mn, value of mn. Then we'll check if x is less than 0, y is less, or y is less than 0, x is greater than or equal to m, y is greater than or equal to m. In all those cases it is out of bound, like it don't exist exactly. So we will do just return, we don't do anything at all. Okay. And or there is one more condition, if इसके बाद if visited x and y, अगर इसको भी already visited, in that case will return. Okay. Yes. Okay, let's start now. Now it is not visited definitely. It yeah. And one more thing, if matrix x and y is not equal to old color, अगर वो color भी same नहीं है तब भी हम return कर देंगे, we don't care. ठीक है. अब now we'll see the conditions where it will fit exactly. Okay. So what we will do now, we know x and y has the old color. We'll set it as a matrix of x and y equals to new color. So now it will become a new color, and then we set the new color. We'll set it as a visited also. Visited x and y बराबर x and y is visited बना देते हैं, इसको true कर देते हैं. Now it is visited, and then finally what we want to do is finally we will check. Now finally we will do the same for others, right? So what we'll do, if x plus 1 is less than m, then we will say, okay, DFS, or we don't need to do that either because that will be already checked in this condition. So we'll directly do DFS matrix x plus 1 y, x plus 1 y old and new value of color, old value of color, and visited. And then again we will do DFS m matrix, then x, then y plus 1, then old, and then new color, and then visited node. Then same thing we'll do for two others. A matrix x minus 1, y, old color, new color. Okay, the same thing we will have to do for the all of them. And yeah, this will mark the matrix as a in a good hand, and that will solve our problem. So now I'll implement it and then share. So as we discussed, I did the same, exactly same. Okay. So I created a DFS method. So where I'm checking, uh, calculating m and n, then checking it if these values x and y are inside the matrix or not. If not, then we are returning. And then if the matrix value is equals not equals to color or already visited, in both the cases I'm returning it. And then I'm setting the matrix to new color, and then visiting it, uh, and then moving to the next left, right, up, bottom, and top neighboring sets. Yeah, that's it, and it's working fine. Now we can move to the next problem. And now I will be talking about the next question. And the next question is this: you are given a 2D matrix containing only ones and zeros. Okay, ones are land, zeros are water. And then an island is connected set of ones and it's surrounded by either an H or zeros water. Each cell is considered connected to other cells horizontally or vertically, not diagonally. There are no lakes on the island, so the water inside the island is not connected to the water around it. A cell is a square with the side of 1. The given matrix has only one island, that's the certain. Then write a function to find the parameter of that island. So we need to figure out the parameter of this particular island. How can we do that? Okay, so to do that, what we can do is let me show you how can we do that. Okay, yeah, it is connecting, just follow it. Okay, so suppose we have a matrix like this. And inside this matrix, I am assuming I will take all the cases, edge cases with the corner cases where matrix can go out of the bound, and then the case where everywhere this one is present, right? So let's start with 1 1 1 1 1 1 1, and then 1 1 1. So now it is approximately, looks like it will take care of all the cases that we want to do, right? So what we'll do is, we know certainly that there is only one island is there, so we'll start to find any of the one in this island. So we'll find starting point के लिए क्या करेंगे, 4 लगाएंगे, इटरेट करेंगे रोज को, 4 लगाएंगे, इटरेट करेंगे कॉलम को, एंड एट एनी प्लेस इफ i and j equals to 1, in that case I will start DFS search. Okay, and then the DFS will send you the edges which that present cell is having, right? So suppose if we talk about the, okay, yeah, so suppose if we talk about any of the cells, let's pick this one. So if we are picking the first 0 0 cell, in that case the edge from the left side, edge from the top side, it is not common at all, and the bottom side, bottom may be 0 hai, so that's why we will count all these 3 edges, and whenever we reach to this particular cell, we will say, okay, return 3, right? So it will return 3, and then if you reach to the this one next to it, then it should return top wala 1, bottom wala 1, that means it should only return 2. And if we look for this particular one which is in the center, then it should return only 0. So for this one only it will return 0, but there is a big but here. For this particular cell there is no edges, that's the case, but if we reach to this cell, but it have these ones, and then if from here we can reach to this one, and then from here we can reach to this one, but it will cumulate all the edges from the which comes into its path. Okay, so suppose if I take an example of that, suppose we assume the first cell that we are syncing it is the middle one, this one is our first cell. Now if I going to see, okay, first assume it is go the right, then top, then back, and then bottom. So first it goes to the right, and then it again goes to the right, then it again goes to right. There it will say there is nothing, so it will return a one edge because we are going out of the bound. So this is the edge, so it will return 1. So now it get 1, right? And then it right is already done, then it will goes to the top, it will say 0, then 0 will say okay, 1 more it will return, then it will go back to the back side, back like left side, but left is already visited, so it won't go there at all. Then it will check for the bottom one, bottom it will again return it to 1. So now, and it will add all of them and then return to the back one. So now this particular one, yeah, this one, this will get 3 return, and then for this one we will start check, because the right one return it 3. Let's just check from the top will return it 1, bottom will return 1, then the cumulative it will become 5. So this is how it will going to be, right? So for that I already wrote the math function, then you can see. So first of all we have the rows and columns m and n, then we created the visited one,
and then we are doing this I and j and then searching for the 1. If anywhere the 1 is found, or if there is nothing is found, then it will return 0. If 1 is found, then it will return self.dfs parameter, depth first search. Okay, so it will going to do DFS. For the DFS, this self x and y in the matrix. Okay, we don't need this, we don't need this. Okay. So if it is out of the bound means if the x is less than 0, that is not possible in matrix. Y is less than 0, that is not possible in matrix. I mean, all the not possible cases, that means it is going out of the edge, right? And for edge we are calculating as 1, so we are returning 1. If the matrix itself is having a value 0, then also it should return 1. And it is already visited. If it is visited, then it will return 0 definitely. Okay, and then we mark this particular as a true, and then we'll check, we'll say ki okay, theek hai, now calculate for all the other ones, for the right one, for the top one, for the left one, for the bottom one, and then sum all of them and then return that particular output. And here we are returning that. Simple. Okay, let's move to the next question. Okay, how they did it. So find island, rows, commas, visited, calculated. Then if I and j के लिए they do the same, it looks exactly same. Not visited, but why, I don't know. Only if the cell is a land or not visited, that's okay. If is land parameter DFS, matrix visited xyz. If out of the bound, return 1. If matrix is 0, return 1. If visited is 0. And else edge, or sum all the edges and return the edges. Okay, cool, looks good to me. Let's go to the next problem. You are given a 2D matrix containing only ones and zeros. Okay, same land and water. An island is connected set of ones and is surrounded by either an edges or the zeros. Each cell is connected to other cells. Each cell is connected to the other cell horizontally or vertically. Two islands are considered the same if and only if they can be translated, not rotated or reflected, to equal each other. Write a function to find the number of distinct islands in the given matrix. Okay, interesting question. So let me tell you the exactly what this question is asking from us. Most of okay, where say we already get it. So we have this particular diagram in which 1 1 1 1, this is one land, this blue one, and the top right side we have second one, and then bottom side we again have blue one. So these have the exact same shape, so they are not the distinct island. So there is only two distinct islands, this one and this one. So we need to calculate that. How can we do that? Okay, interesting. Let's discuss it a bit. Maybe I found some way to do it. Okay, suppose we have a matrix. When will become shapes equal to each other? My question is that. Okay, if the area and perimeters are same, if area and parameter is same, in that case is the shape is same. If that's true, because we can calculate the area and parameter, but I don't know how we can going to calculate the shape altogether, right? Exactly. So what I'm going to do is I will see, suppose we have one shape, this one, let's see this one. So it has the area of 3, parameter as 1 2 3 4 5 6 7 8. Yeah, 8 are the parameter, 8 is the parameter, right? So 1 2 3 4 5 6 7 8, 8 is the parameter. And then we have again one more, this one. Both are not same. They said ki they cannot be fit to rotate, they should be same exactly, right? The two islands are considered the same if and only if they can be translated, not rotated, just can be translated. So if we translate this to here, it won't be the same, even though it have the area of 3, it has the 1 2 3 4 5 6 7 8 edges. Even though they have the same edges. Good question. First of all, one thing is certain, if two lands are same, the area and the perimeter both needs to be same, right? Now the comes the case of, in this scenario, where if you make a mirror image or rotated image, then how you will going to know is that the same, right? So for that, if somehow we able to relocate all of these points to the for this area, then it might be possible to check is it overlap or not. And then the question remains here is, how will the area will start, right? From which point will the area start? And for that, what we can do is we can start checking a node which has minimum of I and minimum of j. If any of the ij in these lands is minimum, suppose for this one I, this one and this one, these are the minimum, and will match that ij from this one's ij, and then check करें, and then compare the areas of both of them. If we compare the land of both of them, then we can find that they are same or not. Yeah, that is a good way. If two lands have the same parameter in the same area, then we can start doing this process by which we can confirm yes, they are same. Okay, but that is a little bit complicated way to do it. I hope, and I'm definitely sure about it, there must be a good way to do it, right? Okay, for that we can just see the solutions right away. or maybe we can implement it. Let me implement it. So I implemented that as I was discussing the same, right? It looks complicated, but okay, we can start now from the beginning. So initially we have the I have created islands. Let me tell you like what exactly I'm doing in this problem. Okay, so yeah, so here you can see. Let me follow through it. So initially what I did is I am having islands. So fundamentally I'm doing three things right now. One is first of all I'm finding all the islands. Find all the islands which have, not which have, like all the islands start point and start point चाहिए and then area and parameter. These three things I'm looking for right now. And first of all I'm calculating that by using DFS. I just search for everything in for, and first of all I iterate the matrix, and if I find any of the cell as a value of 1, then I'm doing DFS on that, and by doing this DFS I'm returning the parameter and also passing the area inside it, so it can calculate the area also simultaneously. So I'm doing this by this DFS, and when I get these islands, then what happens is I iterate over these islands, and then check if the area and parameter is same. Then we'll do and check the DFS, depth first search path. If the path is exactly same, that means both are same, right? Because if we are taking the starting point from there, both should have the same area. If suppose like you might be saying like how you are choosing the starting point, yeah, that's cool. Suppose this is a grid or matrix, okay, and now if you are assuming, suppose here is one, okay, and you are thinking how you will get to know which one is the starting point, okay, and here is another one and both are identical. But for this one we generally, like obviously when we iterate, it start from this way, first it goes to the right and then it goes to the bottom, right? So this is how it goes. So we will find this will become first area and then this will become our first. So we are assuming it if the point, or if the first cell, we assume the first cell if it is present at the left and top, and this assumption is same for all the all of them. So if this assumption is true for all of them, then they have the same or identical starting point of each of them, and if we translate them to at top of it, then their values should match, right? So same thing I'm doing here, and let's see now. First of all, here we going to see the islands. Up until now, up until this portion, I just calculated the islands, okay, and then here I'm iterating inside the island and checking if the island is present. Okay, why I'm checking is island is present? Because if the island is already merged, that might be possible. If we found two are the same islands, then we'll make the second one as a null, because this is already merged to the one. So we have distinct island as one only. So that's why I'm checking. If island is not present, then I'll say, okay, don't do anything, just go to the next one. and similarly x and y will become islands 0. Okay, what I did here is तो इन आइलैंड्स के फर्स्ट इंडेक्स पे आई पुट द पॉइंट एक्स एंड वाई, सेकेंड इंडेक्स पे आई पुट द पैरामीटर एंड थर्ड इंडेक्स पे आई पुट द एरिया. हियर यू कैन सी राइट. तो आई एम फैचिंग दोज वैल्यूज लाइक एक्स कॉमा वाई बराबर आइलैंड 0, पैरामीटर इज आइलैंड 1, एरिया इज आइलैंड 2. नाउ वी गॉट आवर फर्स्ट आइलैंड की वैल्यूज. And then what we'll do is I'll say कि j बराबर I plus 1, and then while j is less than islands we will do the same. New island बराबर this, j बराबर I plus 1. if not island, अगर island नहीं है तो make it continue, and new x new y, again we are getting the point parameter area for the new island. And then we are checking if the areas are not equal, area or parameter, any one of them is not equal, then we'll say continue because they are not identical. If, and then again we are creating a visited matrix to do the DFS for the identity, to check the identity. If self dot identical matrix में we are passing matrix x and y for the first island, new x and new y for the new island, and then visited, that will check ki x and y is visited or not. If they are identical, what we are doing is we are making second one as a none. So now that is not the present at all. Yeah. And what are we doing? So for DFS, we, as we were doing earlier, it's the same thing, but right now we are calculating the area and returning the parameter. Simple. And then for identity, what we are doing is we are checking if x and y is all out of the bound, return true. That means there is no findings that it is false. Then if it is 0, then return true, visited, and return true for x and y, right? And then we mark it visited true. But in the case if x and y are not out of bound, and then new x and new y are out of bound, then we'll say false, because if they are not out of bound, then they should be present, right? And similarly, if the matrix new x new y barabar 0, then also it's false. And then at the 4 of its sides, it should have the same, I'm getting the values and doing the AND operation. So if any of them is false, then it will return the false. Okay, so this is how I done it. Let's move to the next problem. Maybe we can look for their solution also. Yes. So what they do while traveling, okay, ठीक है, यहाँ पे देख लेते हैं. Rows, columns, visited, island set. Okay, they are creating island sets. Then I range rows, j range columns only if the cell is a land and not visited. Okay, in that case what we are doing, traversal we are doing, self dot traverse is land DFS, matrix visited I comma 0 origin. And what is this 0? I don't know. Okay, O0 means origin. Okay, how they are using it I don't know, but let's see. Okay, they are saying this is the origin. Okay, is landset dot add traversal. Oh, whatever it returns, it will oh, they are creating a traversal to it. Oh, nice. Okay, let's see how they are creating it exactly. So traverse is land DFS, so we have the direction. If these are out of the bound, then return the empty array. If matrix x comma y equals to 0 and visited y, then return to empty array. Visited को true कर दिया, then island traversal is equals to direction. So island traversal, I know the direction now, right? And then what we are doing is island के traversal में we'll said कि okay, down, फिर then up, फिर then right, and then left. Okay, whatever we get from their sides, we will adding them, and then we'll say is length traversal plus barabar b, back. Now we are going back. And then return island traversal. So what they are doing, that is interesting. And then they will compare this traversal only, right? And so we did all of it. So in this land of set, island set, it automatically going to be unique values. Interesting. I liked it, kinda, like mostly I like it. Okay, cool. This solution was good, better than mine. Let's go to the third problem. This is the last one for today. So you are given a 2D matrix containing different characters. You need to find if there exists any cycle consisting of the same character in the matrix. A cycle is a path in the matrix that starts and ends at the same cell and has 4 or more cells from a given cell. You can move to one of the cells adjacent to it in one of the 4 direction, up, down, left, right. Okay, if it has the same character value of the current cell, write a function to find it if the matrix has the cycle. Okay, cool. So we need to find the cycle in the matrix. Interesting question though. Don't know will I be able to find it or not, but yeah, let's try it. Okay, I'm just writing down a scenario: 1 1 1 1 1 1 1 1, and we can remove this, that's totally okay. Now if we look at this case, okay, now we can look at this case. It is a cyclic. It is a cyclic. How can you confirm that this is a cycle? To confirm it, so we can start traversing from this direction, that's okay. Then it can goes to this direction. I'm kinda confused now. Okay, yeah. Let me see the solution itself. Okay, I don't know how we're going to solve it. So the solution goes like this. The question follows the island pattern, is quite similar to the number of islands problems. We will traverse the matrix linearly to find the cycle. Each cycle is like a island having cells containing same value. Hence we can use depth first search and breadth first search to traverse cycle all of its connected cells with the same values. Our approach for traversing the matrix will be similar to the one we used in the searching for the islands. We will keep another matrix to remember the cell that we visited. Okay, visited के बारे में बात कर रहा है. Then whenever we reach a cell that have already been visited, we can conclude that we have found what the hell? From any given cell, we can perform DFS to the traverse all the neighboring cells. Okay, having the same character values. Cool. Whenever we reach a cell that have already been visited, we can conclude that we have found a cycle. This also means that we need to careful to not start traversing the parent cell and wrongly finding a cycle. That is while traversing, when initiating DFS recursive call to all the neighboring cell, we should not start a DFS call for the previous cell. Here is a visual representation. I kinda get it. Okay, so this solution what's this solution talk about? Let me tell you. Okay, so here we were exactly. So let me follow it for once more. Now it is saying what you need to exactly do is, if you are starting, sorry, if you are starting from this point, okay, now if you are starting from this point, assume it 0 0, and then you need to remember from where you came from. Okay, let's see next step. It is saying just use the DFS and BFS to traverse anywhere, and if you reach a point like you are traversing this way only, okay, so you were traversing this, and when you reach here and you find it has a point uh, which is the neighboring point, uh, and that is already visited, that means it is a cycle. But there is a problem. There is one specific scenario that fails this thing. Suppose you are here and here, you have only 2 points, that's okay. So you started from the first one and you reach here. If you next time when you are traversing from here, it's the thing like in which directions you can go. You can go in this direction, this direction, this direction, but you shouldn't be traversing at the backwards. If you traverse backwards, then you feel okay, yeah, I find a visited node, right? So we can't do that. So we need to remember the from which direction we came from, and we don't go in that particular direction. That's it. That's the trick only. Okay, so like in the previous case what was happening, so here we came, okay, at the point of 0 0, if you look here, then we came from this direction, so we don't traverse backwards, we only traverse up, right, left, then we reach 1, then we up, back, this, and only bottom, then everywhere we got the null null null, so we go bottom bottom, then this. Here if you see, we came from the bottom, but but we find our nearest visited node at the top, so that's why it's a cycle. Okay, I think this is a cool trick, and now I can implement it pretty fast.
So finally I solved the problem, the same thing what we discussed earlier. So we have this hash cycle, we will be doing the same thing, iterating the matrix, then visited, we'll have the visited node, and then we will store the character and send in the DFS. Initially, visitor direction is direction is dash dash n, because initially it can be anything, because it is not sent from any specific direction. That's why I'm sending a random direction. But other than that, I will be sending a bottom, left, right, top based on the need, right? And then we have this different diff cycle. If this is a cycle, then we'll return the true. So we will return the false. Simple. So let's see the DFS cycle, how it works. We have matrix, XY, the current points, the visited matrix, then direction, then char. Okay, we can remove them, these print things, to debug it. If okay, okay, now it's look quite simple and obvious. So we will calculate m and n as always. Then we'll check if there is a out of the bound. If it is out of bound, then we'll say ki, yeah, it is not cyclic, obviously. Then if matrix x and y not equal to character, if it is not equal to the character, then we definitely say ki, okay, false, and then we don't need this particular thing. Okay, so if visited x and y, then return true. If it is already visited, it is char and it is not out of the bound. And then we'll set visited as true. This particular character is now visited. Then, and this is the turning point actually, visited. If it x and y is visited already, then we'll return the true. Remember that. Okay. And now we will check the direction. If it came from the right direction, then we don't send it to the वापसी right to go. ठीक है. If it is came from the top direction, we don't send it to the back again. If it is come from the left direction, we don't send it to the right. If it is come from the bottom, when to send to the top. So that's why we added these conditions. And then we are doing BFS, and if, yeah, that's it. That's all the problem. If you run it, and you will get your answer. Let's see how they did it. So rows, columns visited, same thing, DFS. So they are doing this -1, -1. So they will be previous X and previous Y. Okay, they will be remembering the previous X and previous Y instead of the direction, but direction also works as it works in our case. Okay, if the previous X and previous X is not matching, then we'll do the same. Okay, as we were doing for the directions. And if the visited is true and already visited, then true. Nahi to we'll make it true. Everything is same. Cool. And this was the video for the island patterns. All of them we've covered here. And I hope you like the video. And thank you.